Now let's say that from here, okay, the insulin released, okay. Insulin release, now when the insulin releases, okay, with the insulin, what is it releasing? Insulin, C-peptide, and also amylin also releases, right? So when they releases, okay, they go to circulation, and circulation, they go to, insulin works into there are three primary targets of insulin, and that you guys have to remember, okay. One is right here, which is going to be your liver. One is the striatal muscles and the adipose tissues, okay? That's what's going to happen. So let's say you have a glucose, right? So what is it going to do? And guys, do you know what's the normal level of glucose in your body? It's like about 80 to 90 milligram per deciliter. That's like a normal level, okay? And whenever you take the glucose level, right? The hyperglycemia, you can say, okay, then that result into what? There's a lot of plasma level of glucose is there, and we want to store that, okay? We want to store that glucose for energy. And so what's going to happen is this glucose, okay, is going to go to circulations, and let's say it's going to go to this pathway, okay, and go to liver, okay. So whenever the liver goes, remember guys, as I said, the liver has this transfer. What is this transfer called? GLOT2 is there, right? GLOT2 is, so GLOT2 is there, okay. So liver takes this glucose, okay. Okay, what is going to happen? And remember, there is a whole pathway running into glycolysis, right? Running into whole pathway here. Glycolysis is going on because you're trying to make more ATP, right? Resulting into what? More pyruvate and all that stuff, right? Not going to go super detail about that. But you guys know this case, right? Now, the most important thing here that you guys should know is that, okay, let's just talk about this, okay, that this insulin has receptors out here, okay? And what is this receptor? These are called tyrosine kinase receptors, okay? The tyrosine kinase receptor is very important. These receptors, okay, I'm not going to go very detailed about that, but ultimately the result is that there are activations of this insulin receptor substrate, okay? And that result into, okay, activations of your two pathway, okay? It depends on what kind of substrate they're bound onto. One is leading to the, okay, activations of your PI3K kinase pathway. And what this PI3 kinase pathway does is that, okay, because if you, in your, here there's a PIP2, okay, phosphatidyl inositol biphosphate, okay, it'll put a phosphate group into it, and it will become what? PIP3, okay? And then later, what is going to happen? That's leading to activations of this guy, which is a phosphatidyl inositol triphosphate dependent kinase activate, and that is going to activate the most important, your AKT, or known as called protein kinase B, okay? This is the ultimate result into it, okay? And this is also located on the plasma membrane right here. Ultimately, and then this guy results to, let's say, RAS and then MAP kinase pathway, okay? Because this RAS and MAP kinase pathway is going to go and work into the, okay, the gene sequence, okay? That's what's going to go into it. But other pathway, this PI3K kinase pathway, which is going to put a phosphate group into PIP2 and make PIP3, which is a phosphatidyl inositol triphosphate. And that is going to activate this guy, the structure called this PIP3 dependent. This P is representing for this one, PIP3 dependent kinase, okay? And that's going to activate this AKT or / protein kinase B. It's the same thing, okay? What did this guy do? This guy enhances the activities of your glycolysis, okay? So remember, when they do that, what is going to happen is that there is an increase of your glucose uptake. Okay, let's just write down glucose uptake. Okay, that's what is going to happen. Okay, let's go down. Not only the increase of glucose uptake is also going to happen, the more glucose is coming here, then what we have to store this glucose in where? Glycogen, right? So glycogenesis will also increase. And how does the glycogenesis increases is this, okay? What is going to happen is that this AKT, okay, what is going to do? Remember, usually glycogen, let's say there's a glucose, right? And the glucose converting into glycogen is called your glycogen synthase enzymes, right? That's it. So if you phosphorylate, okay, if you put a phosphate in the glycogen synthase, this glycogen synthase becomes inactivated, okay? So remember one more thing. This is a little weird concept here. Whenever you put a phosphate group on glycogen synthase, this glycogen synthase becomes inactivated, okay? If this glycogen synthase becomes inactivated, we can no longer, convert glucose into glycogen, okay? But we don't want that to happen here, okay, because we want to make glycogen right here, right? So what this AKT-PKV do is that there's an important enzyme called GSK, okay, which is a glycogen synthase kinase. Glycogen synthase. What they do is that, normally what he does is, this glycogen synthase kinase put a phosphate group into this glycogen synthase, and then if this happens, then your glucose would not able to convert into glycogen, okay? But this AKT or protein kinase, it puts a phosphate group into this glycogen synthase kinase. So when you're putting a phosphate group in glycogen synthase kinase, this glycogen synthase kinase becomes inactivated, and when this guy becomes inactivated, it cannot put phosphate group into glycogen synthase. So if this guy become inactivated, they cannot put phosphate group into glycogen synthase. So glycogen synthase does not become inactivated, okay? Glycogen synthase instead it becomes activated. So we continue making glucose to glycogen, okay? That's what this AKT or PKV do, okay? So now we increases the glycogenesis, but we are decreasing what? Glycogenolysis, okay? That's what is it. Not only this guys do, okay, in your circulations, okay, what also it does is that, okay, there are enzymes, if you guys remember that, the hormone-sensitive lipase enzyme, this enzyme works such in a way with this pathway, right? It also inhibits the hormone-sensitive lipase, it breaks down any sort of like a fatty acid or triglyceride. That's what it does, okay? Instead, what it does is that it increases the insulin, works into the circulation, the endothelial cells of the capillary beds, and then what it does, it increases the, activity of lipoprotein lipase, okay? So when you increase the lipoprotein lipase, okay, if there's a fat or metabolism, like when you have more fats, what's going to happen? You take more fats into the liver and you store it, okay, as a triglyceride, okay? So basically you increase the level of your glycerol, your TAG, okay? Basically you do that. Even in the liver too, okay? That's what it does here. Not only this, okay? Not only this happens in here, okay? Not only insulin does this, there are also other factors that insulin does. But before we go to other, we'll just say something. In the liver here, okay, the glucose uptake is increased, glycolysis is increased, okay? There's going to be increased level of what? Like protein synthesis will happen, okay? There's also increased level of what? Lipogenesis will happen. There will be a decreased level of lipolysis will happen, okay? There is an increased level of glycogenesis will happen because we want to store lots of glucose, okay? We want to store it somewhere, okay? That's what it is. That's what this insulin is doing, okay? Now, not only insulin is doing this, okay, insulin also has receptor on these muscles, okay? What is this muscle here? Remember this muscle is? This muscle, okay, has insulin receptor right here. Let's just make this a insulin receptor. And again, this is also with the same pathway leading into the activations of what? Tyrosine kinase receptors, activations of PI3, right? K, and resulting into what? Ultimately resulting into what? Activations of your protein kinase B and your AKT, okay? And what these guys do is that in the muscles, because usually, when you want to take the glucose uptake, okay, but muscles don't have this GLOT2 type of transporter, okay, which are located in the membrane, okay. They have inside in the vesicles right here, okay, they have a transporter, but this transporter are called GLOT4 transporter, okay. So, in order to take, the insulin comes on receptors, and with this pathway, by this AKT protein kinase B, by putting a phosphate group into this vacuoles, okay, what is going to happen? This started fusing here, and when it started fusing here, what happens? They started showing this transporter, and this transporter is GLOT4 transporter. Okay, so whenever you take a GLOT4 transporter, what is going to happen? This will take more glucose level here. Okay, and they're also like the amino acid transporter here too. Okay, they'll take that too. Okay, that's how they are taking inside the muscle cells. Okay, in the muscles when they take it. Okay, and whenever you take it, what is going to happen to this glucose now? Glucose is going to run the path of glycolysis there, right? But remember, guys, muscles don't have a glucokinase. They have a hexokinase, right? So you have to remember that too. So leading into the pathway, okay, so the activity of the muscles will go up. So there is an increased level of your GLOT4 transporter will increase. And not only this, okay, with the RAS and this MAP pathway, you know, if you need to more glucose, if you need to synthesize more this GLOT4 transporter, they work, and then they also started like building a, you know, making more this GLOT4. Okay, that's what they're doing, but that's from the RAS pathway. Okay, here, so ultimate result is increased glucose uptake. Okay. What is going to happen? Increased glycogen, right? You want to store there too, right? Even increased protein synthesis was also happening there. Okay? That's also happening there, okay? Now, same pathway leading into this. Now what is this guy here? This guy is our adipose tissue, right? This adipose tissue, again, this adipose tissue has, just like you said, you know this now, you have an insulin receptor right here. Again, this insulin is bound with what? This is the receptor called tyrosine kinase receptors, right? They're bound, okay? Whenever the insulin comes and binding to this, these guys get tyrosine kinase receptors becomes activated. They go to autophosphorylations and all, and the activations of this insulin receptor substrate, right? Ultimately, you know, activations of PI3K kinase, and then they will put a, okay, PIP2 there, and then convert into, let's say, PIP3, right? Because they're just putting a phosphate group into the PIP3, and then this will activate like your PI3 dependent kinase, resulting into AKT, protein kinase B. That is what is happening, right? And again, this adipose tissue have what? The GLOT4 transporter right here, look. This is called GLOT4 transporter, okay? And they'll put this, okay, protein kinase B. When they put a phosphate group into this vesicles, they start fusing right here, GLOT4 right here, look. Now, so in that case, you take more glucose, or, you know, that's what it is. That's what is going to happen. Okay? And then whenever the glucose is coming here, right? What is going to happen? There's a glucose level is there. You're running into what? Hold the pathway of glycolysis. Okay? So increased level of glucose uptake is up. Increased level of glycolysis is there. Increased level of your glycogenesis is there. Okay? And this adipose tissue, remember, increased level of glycerol is going to be there. Right? Increased level of triglycerides there, because that's what's going to happen. And the way it works is that, look, this insulin works also so in here, what it does is that it decreases it inhibits the hormone-sensitive lipase enzyme. So it does not allow to break down this triglyceride, because we don't want more glucose or more this triglycerides in your blood plasma, because we already have a lot of this food. We want to store that, okay? So we can use it maybe better later, okay? So we don't want to break down. So it inhibits that pathway, the hormone-sensitive lipase, but as I said, insulin works onto the lipoprotein lipase enzymes, okay? And what is lipoprotein lipase? They are usually for the what? Breaking down, making the free fatty acid and glycerol, right? So that we can store them, okay? So that's what these guys do. They increase the activity of lipoprotein lipase, but decrease the activity of hormone-sensitive lipase, okay? And here, in the adipose tissue, they're decreasing the activity of hormone-sensitive lipase enzyme, right? Now, they put a GLOT4 transporter on your adipose tissue. You bring more glucose into it, right? They're also more taking the triglyceride and free fatty acid, okay? Even the protein synthesis will go up. The increased level of protein synthesis will go up, okay? That's what's going to happen. But they will decrease what? Lipolysis, right? Because lipolysis, okay? Remember one more thing, also the ketogenesis does not happen. So there's a decreased level of, we don't want that, ketogenesis there, okay? Not only this, increased level of glycogenesis, okay? Increased level of glycerol, increased level of triglyceride, increased protein synthesis, okay? Decreased level of lipolysis, and decreased level of gluconeogenesis. We don't want that, okay? We're not big non-carbohydrate sources, right? That's nothing happening there. Now, not only this, okay? So these are the functions, these are what they do in your adipose tissues, okay? Now, this is how insulin actually, all this path are leading into, okay? What is insulin doing is insulin basically, okay, taking the glucose from your plasma, okay, or amino acids, whatever it is, okay, but taking and storing in a liver or in your adipose tissue or your muscles, okay? That's what it is doing. That's the reason why insulin is very, very important, okay? Because whenever there's a high level of glucose is there, okay, we normally call that what? Diabetic, right? Diabetes, right? So insulin helps to prevent, by storing this glucose in different parts of the cells, okay, by, inhibiting or, not allowing it to cause diabetes, okay? That's really, really important, okay? So this is how insulin play in a different role of the tissue. But remember, insulin also play one more thing, okay? Remember how insulin has a different receptor, guys, in different cells? Insulin works in such a way that it's so good. You know what happened? Insulin, every cell has what? The sodium, okay? And then 3 sodiums and brings 2 potassium in. And this is ATPase, right? Every cell has that. Insulin works, okay? In the sodium, potassium, ATPase, in most of the tissues, okay? It works here. And you know what it does? It increases the activity of the sodium, potassium, ATPase. When you increase the activity of sodium, potassium, ATPase, what it does? That means you're taking more potassium inside the cells. Okay? You're taking more potassium inside the cells. That's what insulin does. Again, insulin increases the activity of sodium, potassium, ATPases. Ultimate result is that there is an increased level of sodium, potassium, ATPase. Okay? And what is going to happen is that your potassium level, okay, the potassium level in your cell will go up. And what is the benefits of that? The benefits of that is that, okay, if you have a hyperkalemia, okay, let's write down here. What is it? Hyperkalemia, okay, it is very, very important you give insulin with the glucose, okay? Hyperkalemia basically means that the plasma level of potassium is really high, right? And that can kill you actually, okay? But if you give insulin with glucose, you increase the activity of your sodium potassium pump, and when you increase the sodium potassium pump, your more potassium will go inside the cell, okay? So that way you're trying to reduce the potassium level in your plasma. By doing that, okay, you're treating for the hyperkalemia, okay? So that is also very, very important that you should know about, okay? So insulin has a lot of functions, okay? There is again, quickly repeating, increasing glucose uptake, okay? Increasing glycolysis, glycogenesis, okay? Increasing protein synthesis, okay? By decreasing proteinolysis, okay? And also other functions like, lipogenesis, okay? It increases that. It decreases your lipolysis, okay? And we talked about all that stuff, okay? The blood flow transporters, okay, into the peripheral. These are your peripheral tissue, okay? And your plasma membrane, so you can take more glucose, okay? That's what it is. It's very, very important. Because there's a concept called insulin resistance, okay? Because usually that is happening in the patient, the diabetic patient, which basically means is that, insulin resistance basically means is that, amount of insulin that is produced, it's not able to do any of these functions, okay? That's why you need to produce more insulin in order to have this type of functions, okay? What insulin is doing, okay? So normal amount of insulin that normally get produced, that is not doing its function normally to able to, put this transporter like blood flow transporters or do all this function that we just talked about, okay? If it's not able to do it normally, then we call that phenomena as your insulin resistance, okay? Now, after this, guys, this is all I have for you guys for now. I hope I made it very, very clear to you guys. And please feel free to comment, and also don't forget to subscribe to the channel. Thank you.